Hello, everyone. I am very honored to be here at c0c0n conference. It's my first time in India, and of course, my first time at this conference. And I'm amazed by the how large this conference is and violent this event. And as a cybersecurity professional with over 25 years of experience, I've been seeing our industry evolve, but one area still flying under the radar in industrial control system, ICS, security, often called operational technology, OT security. Today, I will shine light on the silent protocols and blind side in ICS security, how attacker can pierce even air-gapped system, and why we all should care about OT security. I will start by explaining what OT and ICS means and how it differs from the traditional IT. Then we will explore why ICS security has become critical, including real instance example. We'll debunk the air gap myth that often gives a false sense of security. Discuss the Purdy model of the ICS network architecture and look at ways attackers bypass air-gapped or isolated system. We will then dive into what an internal ICS network looks like. Actually, it's often lacks the protection we take for general in ITs, and identify the key target like PLCs, HMI, and proprietary protocols that attackers can exploit. I will describe some hypothetical attack scenarios from airport or railway or ship or nuclear facility for illustrate the impact. We also survey the current state of research and community effort in OT security, for example, pontoon contest, DEFCON ICS village, or we also have ICS city app in DEFCON. So noting that while interest is growing, it's still a niche field. Finally, I have some demonstration prepared with ICS equipment to show these concepts in action, and I will conclude with how you can get involved, perhaps even in the ICS security CTF or village in the future. So first, I want to introduce myself. So I am director of the Red Alert team, a Korea company, NSHC, and I love to find vulnerabilities, especially the zero day. So I am a zero-day researcher, and what kind of, what's your favorite number? For me, the picture is cut. So for me, is zero is my favorite because I've spent many time to hunting 0 days, and I guess I loved this conference because it has 2 zeros. Yeah. So Red Alert is this is scope of research. So basically, we do finding vulnerability bug hunting, so fuzzing, simulating execution, and emulation. So why we do researching emulation? Because IoT, ICS is all the embedded system. So in order to find easy way to find vulnerability, we have to sometimes emulate the firmware. So that's why our research scope has emulation. And also utilities software, mobile software, browser, actually basically everything that has bug we are interested in. So, and now we talk about, in this session I will talk about the ICS SCADA security. So we are interested in this scope and malware. So we do sometimes training. So especially in Korea, we do over 10 years. We give training. So ICS, OSINT, IoT exploitation, blah blah. And also we do the pen test. So because especially ICS SCADA is not easy to the experience to everybody. So for example, we project with Korean nuclear facility agency. So or sometimes we have a branch in Singapore. So we do SMRT the training, SMRT. Finding vulnerability sometimes. So sometimes we do the pen testing also. So the result is also when do project we learn a lot. So with that experience we share with training or something like that. Yeah. So what is the OT operation technology? So let's begin by ensuring we understand the word of OT and ICS. So operational technology refers to hardware and software that monitors or controls the physical devices, processes, and infrastructure. In simpler terms, OT is technology that keeps factories running, power flowing, train moving, and so on. This includes industrial control system like SCADA system, PLC, DCS, HMI. So I will show you more about PLC and HMI later. And so if you are not familiar with the PLC and HMI, that's the OT network, OT technology. And how is this different from the traditional IT? So the goal and environment of OT have historically been quite different from corporate IT system. The one main difference is different priorities. So ICS OT environment prioritize safety, reliability, and availability above all. So security is not that important in OT. So the top concern is that the industrial process, whether it's assembly line or the electric grid, runs continuously and safely. In IT, we often prioritize confidentiality and data integrity, but in OT, uptime and human safety trump everything else. So this fundamental difference in prioritize means OT design and policy diverge from ITs in many ways. So the next difference is there are many vendor-specific and proprietary systems. Unlike the relatively standardized world of the IT, the OT world historically had a few universal standards. many industrial protocols were proprietary or vendor specific, and each automation vendor often had their own communication protocol and system. So actually it is not easy to analyze because there is not standard. Every time we analyze PLC or HMI, we have to study from the scratch because many protocol is not, they use their own protocol. But there are some de facto standard, Modbus, OPC, Propinel, something like that, actually, yeah. But overall, so they use their own. Only recently have efforts like OPC-UA and IEC 62443 security standard start pushing for more standardization across the OT system. And also the difference lies on security through obscurity and isolation. So because of the proprietary nature of ICS protocol and the physical separation of system, organization historically believes these systems were naturally secure. So this is when we do the pen test, people keep saying that this is very secure. You cannot attack, or hackers cannot attack the system because it's air-gapped or the isolation. That's actually that we call it. For decades, ICS network were often isolated from external network. The practice known as rely on an air gap. Yeah, so that's the big difference. And also there are legacy and real-time constraint. OT system often involve legacy equipment or software that may be decade old. The run in real time and often cannot be easily taken down for update or security patch. Updating on ICS can be like replacing a jet engine mid-flight, very challenging. This means many ICS environments still use outdated operating system. And this is true. I saw that they used Windows XP still, and some on some HMI station or engineering workstation. They afraid of the update because they afraid of changing entity because it's working well, so don't want to touch anything. So that's the big difference. To summarize, OT ICS is technology that control physical operation, and it has evolved with emphasis on availability and safety, using many proprietary technologies, and often assuming network are isolated and trustworthy. That model works for a long time, but as we will see, it has created some serious security blind spot now that OT systems are increasingly connect and targeted. Before we continue, I will show you the PLC and HMI, so what it looks like. So we have a very, this is actually a runway kit. So this is airport model that airport has the runway approach light. So when we do the training, we using this kit, and this is programmed that so the student learn how to programming the OT device. So basically, this is PLC is program PL, logic control. Sorry. Yeah. So programmable. So the engineer can program the device, so it can be easily changed. So so we teach how to program this system, and so yeah, this is the EWS engineering workstation. So in this case, this is Siemens. So this program called TIA Portal. So could you, yeah, so this is HMI. So this is for the human. HMI means human machine interface. So so operator can change the state or check the state of what's going on the OT network. This is HMI, and this one is PLC, and Siemens PLC. This, you can see the blink. So PLC has the memory, actually, and if attacker perspective, if attacker is the, let's say, so attacker, so for me, I'm from IT background, so I assume this is just a small computer or small device. So in the memory, I just change cyber attack with cyber attack. If I change the value in the memory, it means it change the logic, and that means sometimes turn off to the light or turn on, or sometimes open the dam gate, or sometimes black out all the city. So this is very, control device is very important, and attacker perspective, this action is just to change the single bit with the network or something else. Yeah, so this is HMI and PLC. And, okay. Yeah, so I think I don't have much time, so I have to quickly explain. So yeah, so we see PLC and HMI, AWS, we see those. So PLC, this is, let's say, this is sense. So some value here, the PLC read, there is the ladder logic. This is what the engineer program. So let's say some certain temperature have to turn on the pump. So that's why the PLC logic is, this is input, this is output. So output side, there is the pump or valve or something like that. And this is the sensor side. And this is PLC, HMI. So they can communicate with each other. Yeah, so why OT? So you might ask if historically there were many cyber attacks on, there are not many cyber attacks on ICS. Why is it such a big deal now? The answer is there is two major reasons. One is convergence of IT and IoT network. Nowadays, it is very rapidly converging. There is yeah. So next one is the rise in ICS cyber instance. Yeah, so I think this one you also know, because there are many benefits of the the remote access or using the updating IT network. That's why OT network is not separated or not isolated, not air gapped. Keep connecting to internet or something like that. So, and ICS cyber incident, So for years, people claim ICS was safe from hacking, but there have been few known cases. So I just want to so Stuxnet, this is very famous one. So using USB drive, they said. So it attacked the centrifuge, many centrifuges, and it used the very it uses the same Siemens vulnerability and using the attack. So very, very famous ICS OT accident. And the next one is Ukraine power grid attack. This one also several times. So very notorious attack. And also there are train or pipeline or rail transportation in 2023, etc. in Poland, and there is oil and gas, and the one very the colonial pipeline ransomware also. It shows that even IT side attack, because the ransomware is attacked from IT sides, and they don't know it affect the OT side, but yeah, it affect the stop the colonial pipeline. And so these examples makes it clear that ICS attacks are no longer historical. Yeah, so next, let's examine one of the most persistent myths of the ICS security. The idea that the air-gapped network is cannot perfect, but and why that no longer hold true? Let's see. So there is air gap. If there is one concept that has dominated OT security thinking, it's the air gap. So the term air gap means the network is physically isolated, no connection to the internet or other unsecure network, not even through a firewall. Many critical ICS are supposed to be air gapped. The belief is that if you keep the control system separate, attacker cannot reach it. So in theory, an air gap is a great security measure. It's like having a vault that's not even connected to any network. But in practice, true air gap are increasingly rare, and even when they exist, they can be breached. So let's move on. How to we will see how to bypass the air gap. Before that, I will talk about a little about the Purdue model. So when discussing how to secure the ICS OT network, we often refer to the Purdue model, also known as the Purdue Enterprise Reference Model, reference architecture. And you can see they're divided level 0, level 1, just similar to OSI 7 layer, but not this is not TCP IP layer. But what the purpose and benefit of the why Purdue model is suggest that is by separating these layer, the Purdue model aims to contain any incident. So if you attacker compromise a corporate laptop, so corporate laptop lies on normally level 4 or level 5, The model dictate there shouldn't be a direct route down to the PLC on level 1. So attacker hits a wall at the DMZ. So so each level is air-gapped or using DMZ. The impact is not. The compromise some device. The attack is not only contained the same level. So it's not. This is not perfect, but it's this help. Remember this, that segmentation is key. So Purdy model gives us the blueprint, isolate the critical control layers as much as possible. Yeah. Okay. And yeah, so how to the air gap get pierced? Okay, so so there are so sometimes using better USB. Just I talk about the Stuxnet USB. Sometimes they use the wireless, even if the policy is not used that, but they sometimes use, or attacker can, if it is physically detached, not physically detached, attacker sometimes attack the device and enable it and using the wireless sometimes. So, and the IIoT, industrial IoT also sometimes they use using the pivoting inside the IoT, inside the internal network, and miscompression and exposed service also. So sometimes you can check the showdown or some searching website, and then you can see some very critical infrastructure devices on there. They're supposed not to connect to internet, but you can check there is. So this is how we analyze or analyze the vulnerability things, and we don't have much time. I think we just move on the demo part. So I'll show you the demo. So if the attacker, it assumed that we assume that attacker is in the network. So actually, the plane, I think in this scenario, I think we assume that plane also compromised it, and plane, the altitude value is not correct in that case, but so so this attack is related to the runway approach line. So so attacker can control. So so if attacker can control that below the 10,000 feet, then if the light is off, so actually it's automatically on now, but if attacker can, 지금 되나요? Can send message. So in this case, Modbus message. So like this. So because they cannot, So this is just attacker simulation. So just like this. So let's. This is a short demo, and And actually, So yeah, so we do the for maybe seven years go to Vegas, and there's DEFCON, and this is the picture of DEFCON CTF. If you go to you will go to DEFCON, please find us, the ICS CTF, or I hope this is the first time in Gokun, but if possible, next year we can through this similar CTF or OT village. I hope so. Thank you very much. Thank you very much.